This video is on solving one-step equations by multiplying or dividing. It's lesson 21 in your book on pages 120 through 126. We're going to use inverse operations to solve our equations. We've already used this in a previous lesson. We know that the inverse of addition is subtraction, or the operation that undoes addition is subtraction, and vice versa. This time we're going to talk about multiplication and division. The inverse of multiplication is division, and the inverse of division is multiplication. So if you ever need to undo multiplication, you divide, and to undo division, you multiply. The multiplication property of equality states that both sides of an equation can be multiplied by the same number and the statement will still be true. For example, here we have 2 equals 2. Now that's a true statement. If we multiply both sides of our equation by 3 times 2 and 3 times 2, then we get 6 equals 6, which is also a true statement. Over here is the more general form of that basically says, if you multiply both sides of the equal sign by the exact same number, your statement will still be true. Both sides will still be equal. The division property of equality states that both sides of an equation can be divided by the same number, and the statement will still be true. For example, if you have a statement like 10 equals 10, which is a true statement, and you divide each side of the equal sign by 2, then you'll get 5 equals 5, which is also a true statement. Again, here's the general form. It just says that if you divide both sides of the equal sign by the same number, the statement is still true. Alright, so here we have some equations, and we want to solve these equations. Now, solving the equation is finding the value of the variable that makes the equation true when you plug it in. So the goal here is to get the variable by itself. You want to have something like x equals a number, so you know what value of that variable will make that equation true. Now, in order to solve these, I'm going to start on the right side over here. So I'm going to start over here at 5x equals 20. Now here I have 5 times x, and I'm getting a result of 20. And I want to get x by itself, so I want to figure out what value can I plug in for x that will make this a true statement. Now, since I'm multiplying 5 times x, and I want to get this x all by itself, I'm trying to get rid of this 5. Now, what undoes multiplication is division. So since I'm multiplying here to undo that, I have to divide, and I'm going to divide by 5. Now, if I do that to one side of an equation, I also have to do it to the other side. So I have to divide this side by 5 also. Now, 5 divided by 5 is 1, so that's 1x, or just x, equals, and 20 divided by 5 is 4. So x equals 4 is my solution. I can check and make sure that the solution is correct by plugging 4 into the original equation for the variable. So 5 times x, which I've solved to be 4, equals 20. 5 times 4 is 20. So now our statement reads 20 equals 20, which is a true statement. So my solution is x equals 4. Down here I have negative 12 equals 3 times n. Now I want to figure out what number I could plug in for n that would make this a true statement. So I want to get n by itself. Since I'm multiplying 3 times n, to get rid of the 3 and leave the n by itself, I'm going to divide. And I have to divide by 3, the number I'm trying to get rid of. Now if I do that to the right side of the equation, I also have to do it on the other side of the equal sign. So I have to divide by 3 here also. When I simplify, negative 12 divided by 3 is negative 4. And 3 divided by 3 is 1, so I have 1n, or just n. So my solution is negative 4 equals n. I can check and make sure it's correct by plugging negative 4 into the original equation for n. So I would say negative 12 equals 3 times n, which is negative 4. Negative 12 equals 3 times negative 4 is negative 12. This is a true statement. So the solution to my equation is n equals negative 4. Now I'm going to move to right here. I've got x divided by 6 equals 8. Now I know this looks like a fraction, but fractions are just division. So I'm taking x and dividing it by 6 and getting an answer of 8. I want to figure out what number I can plug in for x that would make this a true statement. so I want it to end up being 8 equals 8. Now, since I'm dividing x by 6, to undo this division that's happening and get x by itself, I'm going to have to multiply each side by 6. What I do to one side of an equation, I must do to the other. So 6 times x divided by 6. My 6's cancel there. 6 divided by 6 is 1, and I'm just left with x. And 8 times 6 is 48. I can check and make sure that this is my solution by plugging 48 into the original equation for x. So then I would have 48 divided by 6 equals 8. When I divide 48 by 6, I get 8. So now my statement is 8 equals 8, which is a true statement. So plugging 48 in for x would make my equation true. Alright, now I'm going to do this one. The reason that I did this one last is because it is a special kind. It has a couple of different ways that you can do this. Please be sure to write all these examples on this page in your notes, including this last one that I'm going to do. So I've got negative 11 equals 1/4 times w. So we're going to do it just as it is first. I'm multiplying 1/4 times w. Now I want to get w by itself, so I want to eliminate this 1/4. Since I'm multiplying by 1/4, in order to undo my multiplication, I'm going to divide by 1/4. Now what I do to one side of the equation, I have to do to the other side. So divide this by 1/4 also. On this side, my 1/4s cancel, and here I have negative 11 divided by 1/4. Now, I can rewrite negative 11 as negative 11 over 1, and when I'm dividing by a fraction, I'm really multiplying by the reciprocal of that fraction. Now, the reciprocal of 1/4 is 4 over 1. And when I multiply fractions, I go straight across the top and straight across the bottom, so negative 11 times 4 is negative 44, and 1 times 1 is 1. Now negative 44 divided by 1 is negative 44. So negative 44 equals w. That's the solution to my equation. Now the other way that I can do this example is, I have 1/4 times w, so I can simplify that. If I have 1/4 times w, and I'm going to write that as w over 1, I can simplify it. 1 times w is w. 4 times 1 is 4. So now I've got w over 4 equals negative 11. Notice that now it looks more like a division problem. Here it looked like multiplication, but here it's division. W divided by 4 equals negative 11. So I'm going to rewrite it. W over 4 equals negative 11. Now since I'm dividing w by 4, to get rid of this 4, I'm going to multiply both sides by 4. Over here, my 4's cancel, and I'm left with w equals negative 11 times 4 is negative 44. So my solution to my equation is still the same. If I find 1/4 of negative 44, my answer will be 11. But here I treated it as a division problem, and down here I treated it as a multiplication problem. Either way, you'll get the correct answer. All right. Now we have another example. Again, this needs to be in your notebook. Anita is an architect. She is designing a rectangular room that has an area of 126 square feet. If the length of the room is 12 feet, what is the width? Okay, so the first thing we know is she has a rectangular room. So I'm going to draw a picture. When in doubt, draw it out. So here's my rectangular room. I know it's not a very pretty picture, but it has an area of 126 square feet. Alright, the length of the room is 12 feet, so I'm going to label this 12 feet. And what they're asking us, the question here is, what is the width? So we're looking for width, which I'm going to call W. Now, how did I get this area? Well, in order to get the area of a rectangle, area, you multiply length times width. Now, I can fill in some things in this equation. I know that A, my area, is 126 square feet. And I know that the length of my room is 12 feet. I do not know the width. That's what I'm trying to figure out. So I have 126 equals 12W. I want to figure out what is W, so I want to get W by itself. Since here I'm multiplying 12 times W, to eliminate this 12, I'm going to divide. Now if I divide by 12 on the right side, I also have to divide by 12 on the left side. Over here, 12 divided by 12 cancels, and we just are left with W. On the left side, I have 126 divided by 12 feet here. 126 divided by 12 is 10.5. Now, since I'm taking feet squared and dividing it by feet, my units are feet. So the width of this room is 10.5 or 10.5 feet. Now, this is our final example, and this also needs to be in your notebook. For every 4 feet a ladder rises, the base of the ladder should be placed 1 foot away from the bottom of a building. If the base of a ladder is 7 feet from the bottom of the building, find the height the ladder rises up the building. Now they've already drawn a picture for us here. The base is 7 feet from the bottom of the building, and we want to know X right here, the height the ladder rises up the building. So this says for every 4 feet the ladder rises, the base of the ladder should be placed 1 foot away from the bottom of the building. Okay, so that means that if it's 1 foot away, then the ladder rises 4 feet up the side of the building. If it's 2 feet away, the ladder rises 8 feet up the side of the building, because for every additional foot we add 4 feet. If it's 3 feet away, the ladder rises 12 feet up the side of the building. Now notice the relationship between these numbers. So to go from this number to this number, so the horizontal distance to the vertical distance of the building, notice that we have to multiply by 4 each time. So the horizontal distance of the ladder times 4 will give us the vertical distance. Now what we're looking for is the height up. So we're looking for the vertical distance if the height, or the horizontal distance, is 7. So I've got 7 times 4 equals my vertical distance. And I know that 7 times 4 is 28. So if the ladder is 7 feet from the bottom of the building, the height of the ladder is 28